All right, well, thank you so much, everyone, for coming along on a cold, Thursday evening in Sydney. I don't know if it's too windy outside, but no, it's great to see a whole bunch of you. Some familiar faces. I know we've got the Confluent team here and the ClickHouse team and Data Eng Bytes, or the data engineering group. So there's a mix of different community groups here, but it's great to see that everyone comes together in one. Look, I'm from ClickHouse, as you can see with the shirt that some of you could probably get your hands on later today. Johnny's from ClickHouse, as well as Shmita. I think Jeremy's going home maybe. Yeah, but there's a few of us. Maybe a show of hands in the room. Who's familiar and who's heard of ClickHouse before? Great, and keep your hands up if you're using ClickHouse today. So only a few, and that's pretty standard. I think we were just at AWS Summit, and it was interesting seeing the number of people coming up to the booth. And sure, we had some great swag, and we had thousands of people coming up to the booth, but a lot of people asking the question about what is ClickHouse. And I'm sure you'll get a good sense of that from Johnny today when he goes through his talk. So we've got some great talks lined up today. You can probably see and read on the board, but that's in that in now. Welcome James from Laravel. I'm sure some people probably heard of Laravel. It's a massive PHP framework, very exciting company. Hot off the press, they've just gone live today with Nightwatch, or this week with Nightwatch. So James will be talking a little bit about that. Got the Confluent team here, along with ClickHouse, talking about Kafka and ClickHouse. Also the Cloud Shuttle. Where are you, Peter?
Back here.
There you are. So he's going to be talking about a bit about kind of real-time event streaming, real-time CDC at scale. Sorry. So yeah, really looking forward to the talk. We love to keep these as interactive as possible. So if you have a question, just raise your hand. Don't be afraid. I'll give away t-shirts like this, long sleeves, if you like that. So yeah, don't be afraid to ask questions, put your hand up, and yeah, we'll have drinks again at some point, but yeah, help yourself. Looking forward to a great night.
Cool. All right, thank you. Thanks, Jared. Apologies if my voice is a bit croaky today. I've been running a workshop for the last 4 hours, so I'll just start with that. But my name is Johnny Mirza, and here with me today we have Ravi, and we're going to be talking about Kafka and ClickHouse integration. So it's a very dear topic to me. Used to work at Confluent, so now at ClickHouse, so very good topic for us to talk about. So quick intro from Ravi. Did you want to?
Yeah. Hi. So my name is Ravi Bhardwaj, and I work for Confluent as a technical support engineer. I call myself a full stack trace engineer. It's only because I work with on support tickets with customers, and I end up reviewing their full stack traces, which is helpful. And I've been in middleware and messaging space for the last 15 years. I started working with Oracle WebLogic, then Red Hat, JBoss, then worked on Cloudera for a couple of years before moving to Confluent, and I've been working with Kafka for almost 8 years. Thanks.
Awesome. Thank you, Ravi. We are going to do a joint presentation. A little bit about myself. I'm a big data enthusiast working with large data streams and big data sources coming through Kafka. Obviously, there's a very good stream of data coming through, but excited about ClickHouse as well. What you can do with some of those big data streams and analyze that in real time, and looking forward to James's talk from Laravel as well. Also, I added a note about being excited about the future of AI. I really think that's a game changer when it comes to writing queries, creating analytics. Got a cool demo of that today. And what do? So technically I'm a solutions architect at ClickHouse, but I'm involved in marketing, meetup events, community events, sometimes DevRel, and sometimes I do a solutions architect role when I have time. Quite busy. But that's me. I've been at ClickHouse for about 1.5 years now. Okay, so just for the agenda for today, we're going to do some introductions. We're going to talk about Apache Kafka, and then we'll go through and look at the integration with Kafka, some of the improvements that have come in the Kafka and ClickHouse integrations. If we have time, we'll go through a demo and then hopefully talk about have some questions at the end there as well. Okay, so thank you, Joe, for asking the question. I think we'll start with a ClickHouse intro. So for everyone in the room that's not familiar with ClickHouse, ClickHouse was created back in 2009 to solve a problem around clickstream analytics. So at the time, there was no analytical database that could handle the throughput and the requirement to suit a specific need to handle clickstream analytics at a very cost-effective rate. It was kind of built as the Google clickstream analytics sort of competitor in that space. So it's actually where the name comes from. It stands for Clickstream Data Warehouse, which is what ClickHouse stands for. Back in 2016, it actually became an open source product, and it's been widely adopted across many organizations, both ANZ and around the world. Some of your favorite brands like Spotify, TikTok, very large names, Cloudflare, all using ClickHouse to support their real-time analytics, both for internal and external facing analytics. Sorry. In 2021 is actually when ClickHouse, the company, was incorporated. So being an open source product, it was there for a long time, and then 2021 is when the company was incorporated, and the goal was to create an enterprise cloud version of ClickHouse, which now runs across all 3 cloud providers and some others as well. So some of the key features of ClickHouse: it is all SQL based, so everything is a SQL query. We ran a workshop today. It's mostly ANSI SQL compatible. But it's a very familiar language for most users to get access to and run SQL on ClickHouse. It does support lots of writes. We recently had our open house session, open house community event, sponsored event over in the US, where one of the users, being Tesla, I can quote that now, was inserting 1 billion rows a second into ClickHouse, which is quite phenomenal in terms of supporting lots of writes. Sorry. It's also highly distributed, being able to distribute across geo regions, whether you're running across the ANZ and APAC regions or across Europe as well. But the most valuable part about ClickHouse is the way it stores data. So it's all about the storage efficiency, the compression and deduplication that you will get being a columnar store with ClickHouse. It's built to support very fast queries, both inserts and selects, and obviously this is an older slide, but ClickHouse wasn't initially built to run joins. It was kind of there as a function and it did work, but as of the last 6 months, there's been many improvements to improve sort of join performance and speed of running joins in ClickHouse now. So some of the main use cases that we see, it started off as a real-time analytical database being used for clickstreams and customer serving applications, where you've got tens of thousands of concurrent access to ClickHouse. So very large customers there. Cloudflare is actually one of my favorite customers that use ClickHouse for both internal analytics and external analytics there as well. But also now with the integration of joins and support of having more joins, it's being used as more of a data lake type internal BI tool on top of data lakes and running those migrations for internal workloads. And then obviously logs, events and traces with being highly compressed and being able to store that data in a very compressed format. And one of my favorite topics, it's growing so fast, is really around the ML and Gen AI use cases now being developed on top of ClickHouse as well. So a little bit of a technical slide. Essentially there's 2 types of databases. There's your transactional row-based databases, which is your typical Postgres, MySQL type databases, and great for running transactions. However, not very good for running analytics. And that's where typically ClickHouse is used, is a columnar-based store to be able to run very large aggregations across a single column. So that's where ClickHouse is really designed. It's kind of complementary to a system like Postgres or a transactional database to be able to run those analytics in real time at a highly concurrent rate within a specific column-based file. So one other slide that we spent a lot of time talking about today is the way that ClickHouse indexes data. This is actually what makes it quite unique. So ultimately, if we talk SQL, the primary key in ClickHouse is not really about uniqueness. It's about the way that the data is sorted and stored on disk. And it also creates a virtual index called a granule, which allows you to quickly search and query that data without having to read all of the data available. So ultimately, it knows how to read the data as fast as possible without having to do a full table scan. So very technical, happy to get into more details of how granules work in ClickHouse, but it's a virtual index that ultimately allows you to query only the amount of data that you need to query and return that back as fast as possible. So yeah, ClickHouse is based on what we call a log structured merge tree. So it's an eventually consistent merging process or compaction process that happens eventually in the background. So every time you insert data, very topical to Kafka, I believe. ClickHouse is a batch-based system, so it likes to batch data and then write those data into parts or physical folders on the file system, and then batch that data through. So there's some good integrations with Kafka of how you actually work with real-time streaming, and then batch that data into ClickHouse to be able to create those parts, and then ultimately merge that data together. Apologies. So just a couple of architecture slides. There's a whole range of integrations. This is your typical integration slide that you would see from a common integration pattern that we've seen over the last few years. So data streaming from Kafka, there may be some batch ingestion tools, some ETL pipelines as well. We're using things like dbt or Fivetran or other types of integration tools. And then putting that data into a lakehouse type solution where you'd have to transform and ETL that data into an ultimate state, which is typically very batch processed and batch orientated, and also being able to run very highly expensive queries to transform some of that data. We're starting to see a lot of that being replaced with ClickHouse, not all of it obviously, but a lot of that process, especially working with Kafka specifically, and should mention Flink as well. Flink is another great source of data coming through into into ClickHouse. Being able to transform, clean some of that data, work with deduplication, push that data into ClickHouse into an extremely fast table, and then being able to query that data using multiple different tools, whether it's observability tools, data warehousing type tools, or real-time analytics dashboards. Cool. And so the last slide I want to touch on, there's kind of two flavors. One ClickHouse binary, but there's two separate deployment types. So with the open source, it's typically managing shards and replicas to be able to shard that data across multiple nodes. Whereas with the ClickHouse Cloud binary, it's one shard, one replica that all lives on S3, and you can scale those nodes independently up and down, and then add nodes as needed. Cool. Sorry, that's you. Apologies, my voice is, yeah.
Hello. So introduction to Kafka. So Kafka was created by founders of Confluent and at LinkedIn in 2008. The project was open source in around 2010, 2011, and since it was open source, we have seen a huge adoption in users. Around 80% of Fortune 100 customers are using Apache Kafka in their production use cases. So what Apache Kafka really is? So the slide says it's publish, subscribe, reimagined. So unlike the traditional messaging systems, Kafka is built on similar mechanism as WAL files, where it uses a commit log, a distributed commit log, where all the messages that comes into Kafka are written in an append-only fashion on a commit log, and this commit log is distributed across multiple brokers. So there could be multiple consumers, who are producing, or there could be multiple producers and consumers consuming simultaneously from these commit logs. So it not only makes the Apache Kafka highly scalable and suitable for high throughput, but it also creates suitable for data streaming platform use cases. One of the things that is different in Apache Kafka from traditional messaging servers is when you consume message from traditional messaging servers, the data is gone from the queue. So that gets deleted from the disk, whereas in Kafka, the data stays there. So the data is always persisted unless the Kafka's retention policy kicks in. So only when the Apache Kafka's retention policy, and it can be time-based or size-based, only then data is deleted from the disk. Now, while the data is in the disk, or that is, we call the data structure in Kafka as Kafka topics. So while the data is present in Kafka topics, a consumer can consume that messages multiple times. You can consume and reconsume if the requirement says that, but you can have multiple consumers consuming from the same topic. So this says you have Apache Kafka cluster, which can have multiple applications. So applications can be produced as consumers, simultaneously producing messages to Kafka. Then the data is stored in Kafka, and it's a persistent store, and it can be processed and consumed. So Apache Kafka also has a Kafka streams in its project, and that can be used for stateful operations. Now the Kafka topics, that is data structure, you can imagine them as tables in databases. So every event that goes in the tables, you see a materialized view. You can you can imagine Kafka topics similar to that. As mentioned, Kafka has stream processing engines like Kafka streams, or you could use Flink or Spark streaming to create a materialized view on Kafka topics and then run aggregations or even joins for two different streams. So each topic will represent a category, and you can take it from there. So in this example, we have my topic, and it has and we have a Kafka cluster of 3 brokers, and here I've created 3 partition Kafka topic, and I can create even more partition Kafka topics. So this way I can scale my producers or consumers. So if there is a high throughput requirement, I can add a bunch of more brokers in the cluster, and I can increase the number of partitions for my topic. So I can have parallelism at the level of partitions. So that was for high throughput scalability. Kafka also provides failover and resiliency. So there's a concept called replication factor in Kafka topics. So you can create a multi-replication factor Kafka topic depending on the the number of brokers available in the cluster. So in this example, you can see there's topic 1, one topic with 4 partitions, which is distributed across 4 brokers. There will be one partition acting as a leader, which is the producer and the consumers always interact with the leader partitions. Now having the replication factor helps in case of a failover scenario. Let's say you lose one of the broker nodes, then the Kafka cluster will elect one of the replicas as the leaders, and the producer or consumers will seamlessly migrate and start producing and consuming from the newly elected leaders. So producing to Kafka, this is how a usual Kafka producer workflow looks like. So on the left hand side, we have a record producer which has created a producer record, and it has called send. So on the producer side, we need to specify the topic, and you need to specify what data you will be sending. So the data could be a key or a value. Now once you call send, the data needs to be serialized. Although Kafka keeps data in bytes, the data needs to be serialized in a certain format. You could use byte array serializer, which is provided by Apache Kafka project, or you could use a schema registry aware serializers. Once the data is serialized, then the producer needs to know where the message will go to, and that is determined by the partitioner. So the partitioner on the producer side will check the content of the message and on which topic it needs to produce to, and then it will determine the partition. Then on the producer side, we have something called accumulator, where the messages go to, and it is sent to Kafka broker in batches. Now if this is a simplistic view, there's lot of things that goes behind the scenes, but once the message is sent to Kafka broker, if the message is successful, the acknowledgement is sent back to the Kafka to the producer along with some metadata. But if the message has failed, if it's a retriable exception, the message will be retried again. The request will be retried, or if the retries are exhausted, or if it's a non-retriable exception, the producer will get an exception, and the producer needs to handle it. Now the serializers that I was talking about, so we have this lists a bunch of serializers. The way I would like to categorize it is the Apache Kafka serializers, like byte array, string serializer, and then we have schema registry serializers. So depending on what serializer your application is using, you would need to set specific configs. So in the next slide, I show the sample producer code, which has which shows the top 3 are the bare minimum configs that a producer needs to specify. So Bootstrap server is like the connection URL, if you will, in database world. It tells the producer where your Kafka cluster is located. Then key and value serializer needs to be specified. Even though you are sending null as key, the config needs to be specified. In this example, the key serializer is a Apache Kafka string serializer, whereas the value serializer is a schema registry compliant Avro serializer. So I have to also specify the schema registry URL. So if you're producing to Kafka without setting any key, there is a config in the producer which determines the partitioner. By default, the default partitioner, if there are no keys present, it will send messages to Kafka partitions in round robin fashion. So this is what it says. But if you have a requirement, like if again, if you're coming from traditional messaging world where in queues you might have seen it's a messages are sent in FIFO fashion, where you want to preserve the ordering, you can still do that in Kafka. You can either use a single partition topic, which is not necessarily scalable, which is not scalable at all, and if and you can still leverage partitioning or ordering within Kafka by setting a key. So if you are setting a key, the Kafka producer or the default partitioner will always send that message for a particular key to a specific partition. So all the messages for that key will be ordered. So here in the example it shows a record with key A is sent to the first partition, record with key B is sent to the second partition, and so on. So consuming Kafka. So this is the sample code for consumer. Again, you need to specify the 3 configs that we saw in producer, like Bootstrap server, and in case of consumer we need to specify the deserializers, and if it's a schema registry deserializer, we need to also specify the schema registry config. In this example, it would say the consumer is using a subscribe API, and it's subscribing to a list of topics. In this example, I have only one topic, but it can subscribe to multiple topics as well. And once the consumer subscribe to a topic, depending on the offset reset policy, which defaults to latest, you can consume either all the messages from the topic and so on, or you can you can point a consumer to the latest and then only consume the newer messages. So a single consumer is capable of consuming from multiple partitions, but if you have a high throughput application, you might want to create more consumers. Again, unlike traditional messaging servers, Apache Kafka has functionality to create consumer group, where you'll have multiple consumers all participating in a consumer group, and the metadata, the offset information of that consumer group is stored on the broker side. So here we can see the maximum parallelism level of parallelism that we can achieve. Here is 1-to-1. So if you have 4 topics, you can create 5 consumers. And if you create more consumers than your partitions, your consumer, the remaining consumers will be idle. It won't be consuming messages. Again, this is true for the consumers at this point. With Apache Kafka 4.0, there is a functionality released, a feature called queues on Kafka, which allows you to consume using multiple consumers from a single partition, or from lesser number of partitions. So this is the consumer offsets that I was talking about, where the brokers store the consumer offset information. So you can check the status where your consumer has consumed at, or if you want to reset the point where the consumer has consumed, if you want to go back to the earliest or latest or a specific point in time, you can do that. So Kafka Connect is a no or low code connectivity or integration framework. With Kafka Connect, there are a bunch of pre-built connectors, source and sink connectors, which can get Kafka or data from different sources like databases, queues, even HTTP endpoints to Kafka, and similarly consume from Kafka and write to different endpoints. So this is how a usual pipeline would look like. You have a source, it could be a database, and you have a source connector. You are not writing any code, you simply specify where your database is stored at and what table it needs to read, and specify the the security configs. The connectors will fetch data and write data to Kafka, and similarly in sink connectors you just need to specify the endpoint where the data needs to be written back, and the connector will read data from the Kafka topics. And while it is doing this, you can choose the conversion format. So you can use like how we had the serialization format in Kafka producers. With source connectors, you can say if you want to use Avro converter, like you can use Avro converter or protobuf converter, which is schema registry compliant, or you can use open source default Apache Kafka converters like JSON converter, byte array converter, and this is supported by Sync as well. And you can also transform data while you're writing data to Kafka, or while you're consuming data to a different endpoint. You can create chain of multiple transformation. So you can do filtering if you want to drop anything, if you want to enrich your data. You can write custom transformation and plug it in. But these are expected to be lightweight, and these transformations are done on single records, so you can't have stateful operations on these transformations, but they are really good when you want to do a simple transformations. So yeah, you can log into developer.confluent.io to learn more about Confluent and Kafka and other related technologies. So yeah, this is it for me.
Thank you. Almost finished. I actually have a question for Ravi. Can you convert data types or schemas serialized from the way in to the way out? Have different serializers?
Not within Kafka, but you can use schema KSQL DB or Flink. So.
Cool, thank you. I just wanted to confirm. Okay, that was awesome. Thank you, Ravi. So we're just going to look at a demo now. We're going to look at an integration of how to work with Confluent, Kafka, and ClickHouse, and some of the different deployment options that are available. So real time, yeah, kind of. Real time means a lot to a lot of different people, but it's very fast. That's kind of all I can say when it comes to this integration. So there's a couple of different ways. There's actually 3 different ways of integrating Kafka to ClickHouse. So one of them is a fully managed service from ClickHouse. It's called ClickPipes. And ClickPipes is a fully managed, Ravi showed the consumers there. It's a fully managed Kafka consumer that runs in ClickHouse Cloud, and it connects to Confluent, including schema registry integration, and it auto scales out, scales up. I think we're going to have a demo of this today as well, of how that works. But it's a fully managed Kafka consumer or consumer group or client that lives in ClickHouse. It's called ClickPipes, so it's a very native way. It handles schema changes very well. It works with all the different serializations, whether it's Avro, protobuf, or JSON, and byte string as well. So that's kind of the cloud native experience, but from a ClickHouse open source perspective, there's a couple of different ways. There is a table engine, so ClickHouse has a concept of table engines, which is a direct integration from ClickHouse out to Kafka in this particular scenario. So you can use a ClickHouse table engine to go and consume data from Kafka. Typically, you would use a materialized view on top of that to go and read that data in real time, but we can definitely discuss that later if you need to as well. There's also, as Ravi mentioned, there is a Kafka sync connector, which is actually managed by ClickHouse. So ClickHouse maintains the open source sync connector, and I believe it's going to be fully managed. It's coming soon. It's going to be fully managed in Confluent Cloud as well. So it was traditionally a bring your own connector model, so you would deploy that as your own self-managed connector. But now it's going to be fully managed as a fully managed connector in Confluent Cloud as well, or you can deploy it in Kafka Connect on open source. All right, so we just want to do a quick demo. Hopefully we have time for this. I just want to show the integration. And I guarantee you I've been logged out of everything here. So let's see how this all goes. Yes, I definitely have. Sorry. I just have to log back in. Apologies for this. Okay, so this is my Confluent Cloud organization that I have access to. And there you go. So what I have here is, obviously the UI's changed quite a bit. It looks amazing. Very good integration there. So what I want to focus on is if I go to my environment, it's the default cluster that lives there. It's shared within my team. Cluster 0, you can see there's a bit of data being produced into that and consumed from that already. So what I have here is, it is using a topic. There's no connectors in this regard. We're not using connectors or anything like we're not using managed connectors at the moment. But what we have is basically an EC2 instance that's running and generating a whole bunch of data into this world news topic. So quite a lot of data that's going through. And yeah, that's quite a bit of information that's being pushed into Kafka from this EC2 instance. And then we also have a ClickPipes client that is being run to consume that data. So I can see that's the particular client ID. And that's consuming that data from one particular topic, world news there as well. So yeah, that's a Kafka integration, very stable, very solid, high throughput as well. Now if I pivot over to ClickHouse, this is what ClickHouse looks like. So what I have here is, this is my ClickHouse cluster. And then if I go to my data sources, this is the ClickPipes that I mentioned earlier. We already have a topic from Confluent Cloud that's running. It's called test demo. And this is pushing quite a bit of data. So it's, yeah, 13 gigabytes, I guess, worth of that ingestion pipeline going through. All the different settings, the topic information, the schema, the field mappings, all the definitions, all defined from that particular, this all gets inferred at ingestion time as well. So ClickHouse will identify the schema and understand all of the different data types and so forth. And then from there, I can quickly run some queries. So for example, let's just do hopefully that works, a quick count of how many records in the table. So there's 267 million records in this particular table. So that's constantly changing and obviously being updated in real time, hopefully. Yeah, I'm sure there's a few extra zeros after that. But then if I describe that table, sorry, you can see all of the schema being defined, all of the information, that integration coming through from ClickHouse and Kafka there as well. So I thought I'd share another demo. So instead of writing a whole bunch of queries on top of this data, I just thought I'd ask AI to do it because it was just a lot easier to do that. So I picked up my Claude agent that has integration to this ClickHouse MCP and just asked it to analyze the global news dashboard with anything with the name of ClickHouse associated with it. So yeah, produced these results coming from that topic. 249 million total interactions, 12 million subscribers, countries by activity, so mostly in the US, and then obviously like the content performance and daily activity. So yeah, this was all generated from AI on top of ClickHouse with a Kafka integration pipeline in near real time as well. Cool. All right. Okay, so yes, ClickHouse plus Kafka equals love, definitely. It's a very good pipeline and ingestion stream as well. So round of applause, that's definitely really good downstream stuff. And that's all we had today. So thank you very much, and please keep in touch. We do meetups in Sydney, Melbourne, ANZ quite regularly. So if anyone wants to present, please feel free to reach out. We also have our community Slack group, always available on there as well, and anywhere on LinkedIn. Yeah, come chat to us later as well. So thank you. Thank you, Ravi.
Thank you.
Question, yes. Oh, sorry.
I think I'm not in it. Regarding the last AI bit that you just showed,
yep.
Is it just like a text to SQL engine that's running on your screen? Like, do you think the Claude is just taking a query that you pass, it's converting that prompt into a SQL query and then providing you the output?
Yep, so it's essentially that. So Claude has an integration to ClickHouse MCP. Actually ran it and it actually failed on this one, but you can see the prompt, but then you can quickly see list the databases, for example. It found all the different databases, and then it went through and said, okay, it found world news, and then it runs this reasoning model to go and write the queries and create and generate those dashboards. It actually failed on this return because I haven't got the paid version of Claude, but apart from that, it works. But yes, that's how you generate that. Good question. Yes.
How ClickHouse manage the restores and stores from databases?
So yeah, just to repeat that question, how does ClickHouse manage the backup and restore of databases? Good question. There's two different ways. So obviously with the open source version of ClickHouse, there is a ClickHouse backup restore command that you can do, and it kind of does an in-place upgrade backup as well. I'll just show you the cloud version because it's a little bit easier, but with the cloud version, it does have built-in backups and configurable backups there as well, so you can configure that. Right now, the backup retention is every 6 hours, but it will get more granular than that in the snapshots coming soon as well. But good question. Yes, sorry.
Yeah, with the cloud product, is that available in this geographic region?
Yes, it's available in AWS, AWS Sydney. Yeah. Sorry, I don't have access to that. But yes, it's available in AWS Sydney. Yeah. Cool.
What's the difference between the open source version and the cloud version that you mentioned?
Yeah, great question. I touched on it, and apologies, my voice was crackling a little bit at the time. The main difference with the cloud version and the open source is the separation of storage and compute. So for example, yeah, with the cloud version, there's one replica, one shard. It all lives on S3, and you can scale those nodes independently and scale up, scale down, scale out. Open source, still great. You can do quite a lot on one single ClickHouse server. It's an amazing tool and product, but if you do need to scale out, you have to shard your data and manage replicas as well. Yeah. So.
After that, but this is related to the same.
Sorry.
I read about ClickStack, like your sort of observability kind of trying to go against other incumbents. Can you briefly sort of elaborate on that? Is that what? Yeah.
Yeah, so the question's about ClickStack. Interesting name that we came up with ClickStack. So it's an interesting question. ClickHouse has just organically been adopted to be used for observability, just because of the compression that you will get from storing the data in ClickHouse. If I give you an example of what that looks like as well, you'll be able to see, so for example, I'll just pick any table here. I can, probably see this, but the compression in ClickHouse is quite amazing. I can show the demo of that. The challenge with ClickHouse is it's never had a UI on top of it. It's always been this fast database. And then Grafana was being used as the go-to tool for observability, and a lot of the ClickHouse observability use cases came from more so elastic workloads, or some of those types of workloads, not always, but having that lack of UI, and especially the discovery type feature of being able to drill down in specific logs and traces is something that was missing, particularly in Grafana. And that's why we actually started using ClickStack, which was HyperDX internally for our own observability. And then, obviously ClickHouse invested in that company because it was already built on top of ClickHouse to provide that gap in functionality. So that's where that came from, that piece, because we use that internally.
An example, like a professional, like is that available as an offering at the moment? Like does it have like the alerting, anomaly detection, SLOs, all that sort of other stuff you'd expect, or is that kind of, I guess, still to come? Like I guess I'm just, like I'm an observability nerd, and kind of, I always get challenges with the amount of data gravity and stuff, and the cost with traditional providers, and just trying to understand like what the value prop is for you guys.
Yep, good question. It's a great question. I don't think it's going to replace Grafana completely. It's never going to be dashboarding or anything like that. Grafana's got some great tools, the loading capabilities, functions built into it. The only part that was lacking was the discovery drill down piece. That was the only part that we were, actually internally, we couldn't use it, so we ended up using HyperDX and acquired the company. So it's a combination of those products, but the cost benefit is quite amazing, and the performance and speed in ClickHouse will be pretty good as well. Yeah. So.
To get started with HyperDX, I believe you can just start a trial, right? Directly with HyperDX. So that's how you can start using it. It's going to integrate with ClickHouse eventually. I don't know how long away that is, Johnny.
I don't know, but I would imagine that we're going to start seeing more and more tabs popping up on the left here. So the first thing was the data sources. So this is sorry, go off topic a little bit, but this was a Postgres migration capability, which was announced, and also a ClickHouse acquisition. So now that's become part of ClickPipes to do Postgres CDC. I'd imagine ClickStack, if that's a name, is going to end up being there as well. Yep. Sorry, one more question.
Among the fastest analytical database, I think you're the largest too, isn't it? Because of the amount of data that comes into your system. My question is, how big is your database? Because you're always consuming a lot of data. How do you keep it current? In the sense, data over a month forward is no longer relevant. Right? The data that's decoded is actually relevant for whatever report. How do you keep it current?
Sorry, how do we keep the database current? Is it?
How do users, customers, keep the data current in the database? Because anything more than a month old is no longer relevant. So you already keep the latest data.
Yeah, it's a good question. We generally keep data quite long because of the compression. So I'll give you an example. We migrated away from another observability tool. We have almost 100 sort of petabytes of data of ClickHouse in terms of all of our cloud logs. They've been compressed down to under 20 terabytes worth of data. So I've got to confirm that number. But it's definitely being able to have that compression and keep the data longer in disk as well. So that's, ultimately the compression and deduplication that ClickHouse provides allows you to keep the data longer. If you needed to, you can always offload it as well, but it's already cost effective and storage is quite cheap. It's on S3 anyway. And then you can query that data quite effectively as well using specific indexes.
ClickHouse is managing the data on the customer. Yeah, so you couldn't take it offline for relation storage, or you want us to tell you that you don't need the data anymore. Right, the whole
Right.
keep some data.
No, so I mean, there's two things here. The ClickHouse is a cloud service. We don't manage the customer's data specifically. That's a service. Customer has access to that. ClickHouse doesn't have access to customer data. But there are functions like time to live, things like that, where you can apply at a table level, which will automatically archive data or delete data after a certain period as well. Yep. Cool, great questions. I'll take one more, if that's okay. Any questions for Ravi, by the way?
I was wondering, we were speaking about schema changes before in SQL. Would you recommend generally that for setups that are changing at a faster pace to integrate it rather with Kafka, so the data is already deserialized?
Yeah, definitely. I know ClickHouse has a really good JSON function, but for performance and speed, probably Avro is going to be faster and better anyway. And then working with schema registry is going to provide that. With ClickPipes specifically, it will automatically go and update the table. So it'll add columns or remove columns automatically and alter that table as needed. But yeah, absolutely.
Because before part of the workshop, we were diving a little bit into deserializing the data. That's kind of what we skipped at, right? We have already adjusted the Kafka schema accordingly beforehand.
Well, I mean, Kafka handles that. So Kafka deserializes built into the Kafka consumer will deserialize the data. But specifically, it talks to Confluent schema registry to understand the schema headers for Avro, protobuf, so forth. But the deserialization happens at the consumer level when you run that deserializer for that particular data type, that data format. Yeah, good question. All right, well, I think we'll wrap up there. Thank you, everybody, and please come and talk to us later.